Okay, so basically with a probability of Q we terminate and return C, and with the probability of 1 minus Q we do not terminate array and compute recursively compute the color. Okay, now what we want to do is let's say, okay, let me clean this part. So let's say your f prime is defined like that. So f prime is the final value that you return. Okay, so f minus qc divided by 1 minus q. So this is basically the computed color. So this is this f by f, I mean this is the computed color. Okay, so this is for the rays that are not terminated. Okay, so the random number that you generated is greater than q. Okay, is greater than the probability of termination. Now on the other hand, if the random number that you generate is less than q, less than or equal to q, we return the constant color. Okay, now this is interesting. So this is basically, there are two possibilities. You either terminate or don't terminate. So this is what happens when you don't terminate, and this is what happens when you terminate. Okay, so what is the expected value of these two options? So with 1 minus q probability, okay, so remember q is the termination probability. So with 1 minus q probability we don't terminate and we return this f minus qc 1 minus q. Plus with q probability we terminate and we return a constant color. Okay, so if you actually add this up, because these two cancel and then these two cancel, this is going to be f. So the expected value here, the estimator that is computed using Russian roulette is equal to the actual value that we want to compute. Okay, so there is no, this is the explanation of why there is no bias. Okay, so there is no bias, but it doesn't mean that there will be no noise, right? So in fact, images generated with Russian roulette, if you just use Russian roulette, may end up being noisier than the images generated with a fixed recursion depth. Okay, so now let's talk about this part here. So with probability of q, we terminate. Okay, now how do we define that probability? What is the probability of q? What is q? Okay, so let's say our probability of q may be equal to, first of all, it has to be a probability between 0 and 1. Okay, so cos theta is a possible alternative. Okay, so cos theta, but let me clean this first of all. Let's first understand the situation here. Let's say we have a ray that intersects this point x, okay, and let's say this is the surface normal n, and we have our randomly generated direction wi. Okay, now if this wi is closer to the surface normal, for example, okay, so I'm going to explain one possibility. If this wi is closer to the surface normal, you most likely do not want to terminate this ray because it has the potential of making an important contribution. The light that comes from a perpendicular direction has more effect, right, due to the cosine theta term in the rendering equation, right? So you don't want to terminate this probabilistically, but maybe if you have a large theta, if you randomly selected this wi so that you have a much larger theta, okay, this time you may want to terminate. Okay, so you may say that q is actually equal to, so if we say cosine theta, and let's call this is theta, cosine theta is large for small theta, right? Cosine 0 is 1, okay? So it's better to define Q as 1 minus cosine theta, okay? So what does it mean? This means, let's say theta is a large value, okay? Theta is, let's say, 89 degrees, okay? Cosine theta is 89 degrees. So cosine theta is going to be something like 0.0001, okay? Because 89 degrees. So your termination probability will be high. You really want to terminate, give high probability to terminating those rays. Okay? But this is a probability. It doesn't mean that you are definitely terminating this ray. The second factor in deciding the termination is this random number. So you may have a termination probability which is very high, because let's say theta is 89 degrees and cosine theta is and 1 minus cosine theta is very close to 1, right? But if this ray happens to be a lucky ray, then the random number generated for that ray may be very small, right? Or it may be very large, so still exceeds Q, and we don't terminate. So that probabilistic behavior of Russian roulette makes it bias-free. And of course, we must weight with this. Use weighting, so 1 minus Q. So it's not terminated with 1 minus Q probability. Okay? Now, one thing that we should be careful is how to select this C. Actually, surprisingly, the value of C doesn't matter for the expected value, but in practice, most ray tracers use 0. So this C is usually like 0, 0, 0 for RGB values. Okay? Although mathematically it doesn't change anything, but realistically, when you look at the pictures, it does. Now, in terms of combining fixed recursion depth with Russian roulette, which I believe is a better approach, is you can do the following. You may have the minimum recursion depth. Let's say a minimum recursion depth of 6. Okay? So you do not terminate until you reach at least level 6 in your recursion. But after level 6, you may apply the Russian roulette. Okay? Now here I have simply shown you a simple